Hello everyone, my name is Emna Bouzaiene. I have just started my master's at the National Institute of Scientific Research in Quebec. Today I will be presenting my research project titled Assessing the Geothermal Potential of Mine Water in an Active Mine in Quebec, Eastern Canada. This work is supervised by Professor Jasmin Raymond and Félix-Antoine Comeau and is carried out in collaboration with industry partners such as Agnico Eagle, Blé Industries, and Induction. In this presentation, I will walk you through the motivation behind the project, the methodology we're using, and hello everyone, my name is Emna Bouzaiene. I have just started my master's at the National Institute of Scientific Research in Quebec. Today, I will be presenting my research project titled Assessing the Geothermal Potential of Mine Water in an Active Mine in Quebec, Eastern Canada. This work is supervised by Professor Jasmin Raymond and Félix-Antoine Comeau and is carried out in collaboration with industry partners such as Agnico Eagle, Blé Industries, and Induction. In this presentation, I will walk you through the motivation behind the project, the methodology we're using, and the outcomes we hope to achieve. Before diving into the project itself, here's a quick overview of the mining sector in Canada. So, Canada is a global leader in mining with over 14,000 active and closed mine sites across the country. In 2022, miner production reached an impressive 550 million metric tons with a total production value of over $75 billion. In Quebec alone, there are more than 200 active mines and nearly 400 closed ones. This strong mining presence contributes significantly to Canada's economy, but it also comes with serious energy and environmental challenges. As it is one of the most energy-intensive industries in Canada, most mining operations rely on fossil fuels, which results in high greenhouse gas emissions. As shown here, greenhouse gas emissions from this sector rose from 63.9 million to 77.2 million tons of CO2 equivalent between 2014 and 2021. And this upward trend is expected to continue until 2035. It is therefore essential to explore renewable energy solutions. A promising option is the application of geothermal energy. A new approach is to use the large amounts of volumes of water continuously pumped from both active and abandoned mines. Mine water is often seen as a waste, but it can be a low carbon source of thermal energy for heating and cooling buildings. In abandoned flooded mines, this concept has already been successfully implemented, both in Canada and around the world, demonstrating its technical and economic feasibility. Several pilot systems are already in operation in abandoned flooded mines across Canada. A well-known example is the Spring Hill coal mine in Nova Scotia. Since 1989, it has supplied geothermal energy to heat and cool a nearby industrial complex, saving around 600 megawatts hours per year. Another example is the Goyer Quarry. It's a flooded open pit mine located in Saint-Bruno de Montarville. Since 2006, it has been used to provide geothermal heating and cooling for a nearby condominium complex. The system has helped residents to cut energy consumption by 40 to 50% compared to conventional systems. In the case of active mines, only a few studies have been conducted to evaluate the geothermal potential of mine water. These studies are promising, but they remain largely theoretical. A good example is the case of the Eleanor mine located in James Bay. In 2020, a master research conducted by Edgardo Alvarado evaluated its geothermal potential. The proposed system used dewatering water in a heat pump setup, and the study estimated it could cover 35 to 39% of the mine's heating needs. A similar study was conducted in China in the Xinyu coal mine. It also showed strong potential, replacing over 12 million tons of coals and significantly reducing greenhouse gas emissions. These operational cases confirm that the approach is technically viable. But the work in active mines is still limited to theoretical studies and modeling. In fact, there is currently no pilot system documented in the scientific literature that demonstrates the use of dewatering water from an operating mine for geothermal energy recovery. This lack of field data represents a major barrier because without proven operational examples, mining companies are hesitant to invest in these systems. And because active mines present technical challenges that simulations can't fully capture, only real-world testing can provide the insights needed to move from concept to implementation. This is where our research project comes in. We aim to develop and test the first pilot geothermal system using dewatering water from an active mine. More specifically, the project aims to quantify how much thermal energy can actually be extracted on site, understand how temperature variations affect water chemistry and system performance, and explore how this approach could be scaled or adapted to other active mine sites. To achieve this objective, the project will be divided into 4 parts. The first step is site selection. Our industry partner, Agnico Eagle, is providing access to 3 of its operating mines in Abitibi, the Goldex mine, Canadian Malartic mine, and La Ronde mine. One of these sites will be chosen to host the geothermal pilot system based on mine dewatering flow rate, water temperature and chemistry, and the site configuration. The second part of the project focuses on thermal hydrogeology. At this stage, we will install the pilot's geothermal system and run it over several weeks, both in summer and winter conditions. Using temperature sensors and flow meters, we'll record system performance in real time. These results will allow us to estimate the annual energy potential and evaluate how well the system functions under real operating conditions. The third part of the project is geochemical analysis. In parallel with the thermal testing, we'll monitor water chemistry and use lab tests and geochemical modeling to predict and better understand risks like corrosion and scaling. And the fourth and final part of the project is to combine these results to create a practical guide to help design and operate geothermal system in other underground mines. For my part, I will be working on the thermal hydrogeology aspect of the project. This is a simplified representation of the proposed geothermal system for the active mine. The process begins with mine water pumped from underground galleries, which is directed to a retention basin. From there, the water is pumped into a plate heat exchanger where it transfers its heat to a secondary fluid circulating to the other side. This heated fluid is then sent to a geothermal heat pump, and the extracted heat will be released into air. Throughout the process, temperature and flow sensors are installed at key points to monitor system performance. Here's the project timeline. This project will last 3 years from January 25 to December 27. The field work to install the geothermal heat pump is set to begin this summer. This will kick off the experimental phase, and we aim to complete the system installation and start testing within the first year. Over the next 2 years, we will focus on collecting data, running simulations, and analyzing the results to optimize the system. To conclude, this project goes far beyond a small-scale field test. It aims to generate real operational data on geothermal energy recovery from active mines. By combining thermal and geochemical monitoring, we'll be able to estimate the true energy savings, evaluate the system performance across seasons, and identify key risks such as corrosion and scaling. One of the major strengths of this project is the collaboration with industry partners. The geothermal pilot system will be portable, meaning it can be reused at other sites, making this not just a demonstration, but a scalable solution. Ultimately, the goal is to provide mining operators with tangible evidence of how geothermal system can reduce greenhouse gas emissions, lower energy costs, and turn mine water into a valuable resource. And by doing so, this project will help pave the way for the integration of geothermal energy in the mining industry. Thank you for your attention. If you have any questions, don't hesitate to ask.